distance each day. From the source it spreads so wide.
Hello. Today we are going to talk about light polarization. As you know, light is an electromagnetic waves. So we have an electric wave and basically a magnetic wave which is perpendicular to this electric wave. So they are perpendicular to one another, so they have an angle. If this is electric field, let's say this is electric field, E. So this is going to be magnetic field. So they have 90 degrees between both of them. And as we know, the change of electric field creates magnetic field, and the change in magnetic field creates electric field. So the idea here for a natural light or unpolarized light, the electric field direction, it is moving in every direction. Might be horizontal, like for example this way, it's moving like this, or it could be vertical direction, or it could be horizontal, it's moving like this, or it could be basically anywhere. So the electric field could be moving like this in the space, or it could be moving with an angle in the space, or horizontal in the space, or any direction. Which, if we say that this is basically, we would like to say the direction of electric field. Here electric field is going to be vertical, here is going to be horizontal, or basically it could be everywhere. It is in all directions. Let's say it's rotating electromagnetic waves. Okay, so it's all directions. The idea of having a polarizer, it's basically to have certain polymer or certain material, that these polymers have certain lines or are made in a certain way, so that when the light or unpolarized light go through them, so that the particles inside the polymer start to oscillate in certain directions, so they make the electric field only oscillate in the same direction of the polarization direction, or the filter itself. So if you have this kind of shape of electric field that's going everywhere, and it goes through a vertical polarizer, so in this situation, the outcome of electric field is going to be in this direction only, in the vertical direction. Okay? So here we have a light that's going everywhere in all directions, unpolarized light with specific intensity. Then it goes through a polarizer, let's say a vertical polarizer. So the outcome here is going to be an electric field in the vertical direction, and the intensity in this case is going to be, if this, let's say it's this I naught, intensity naught, and this is going to be I naught over 2. What if we make this electric field the polarized, this one becomes a polarized electric field, or light, and this light basically, the electric field is oscillating in the vertical direction. Then basically if we make this one go through another filter, but this filter basically it has a different orientation, some angle with the vertical line. Okay, so if this one was the vertical direction of the polarizer here at this location, and this one is going to be in this direction, so there's some angle between both of them, a theta. So basically when the electric field or the light, the polarized light, the vertical one, go through here, so the outcome is going to be an electric field that's actually in the same direction of this polarizer. Here, this is going to be the oscillation of the electric field. And the intensity in this moment, let's say this one is going to be 1. Okay, so here the I2 with this angle is going to be equal to I1 cosine theta, the angle between the polarized light here and the direction of the polarization here, which is this angle, square. So this is the new intensity of the light. So for today's experiment, we are going to do this. We are going to have unpolarized light. We will measure the light intensity. Then we will put a vertical polarizer. We will measure the intensity after. It should be I naught over 2. Then we will put another polarizer, and we will start to change the theta, this angle, and we measure the outcome of the light intensity after. I hope that this one, and let's go for the experiment. So these are the tools for the light polarization. So we have the LabQuest, we have the optics bench, we have here 2 polarizers, as you can see here. So the zero direction, basically the electric field direction, it's basically vertical, pointing to the direction of the 0 degrees. When you rotate, basically the electric field direction is going to rotate with you. We have the light sensor. We have the light sensor holder. Disc aperture holder. It has different sizes, different shapes. And we have the light source itself. And of course, the lab manual. So now let's do the setup. So we have the light source itself. Let's connect it to the adapter, and we can see turn on and off. Then we place it here. Then we would like to take the aperture self holder, and we place it exactly in front of the light source, no distance in between. And I would like you to select the smallest aperture here. Okay, it's better to use a laser, but due to some difficulties to have a laser holder and light sensor holder for the laser, it was not convenient, so I'm going to use this one with the small aperture. Then after that, I'd like you to put the light sensor holder, like that. Tight it. Okay, place it here. I need you, when you turn on this, you make sure that the light going out of the aperture is going directly to the light sensor. Then after that, I'd like you to make sure that the light sensor is very close to the light source, like this, not very far. Just a small distance in between, maybe less than 5 centimeters. Okay. So we can see here the light luminance. It's around 4,500. Let's turn off the light source, so it becomes 2,900. Let's go and turn off the light. So after turning off the light, it seems that there's some offset. So this is the initial without light. It's 2,900 for the intensity of the light. So now we are going to turn on the light. So we can see that the light intensity is 4,500. Let's have a zoom in to see it. And from here, I'd like you to place the light polarizer. Basically, make sure that the zero direction is vertical and it's pointing upward. Okay, And so now this is the initial state. We have the light source, it's pointing to the light sensor. We have the measurements of 4,550. So now we will put the polarizer, it's pointing up here, as you can see. So now the value becomes 3,600. Okay, record this measurement. So now I need you to place the second polarizer on the top of the first one, and I need you to make the angle between both of them 0. So still this one is pointing up. Then you take a measurement right now. It's 3,400. Okay. Then I would like you to start to rotate the second polarizer with some angle. Okay, and start to measure the angle itself. So now, for example, it is at the opposite. Now it's at 20 degrees, and you record the light intensity. Then make it 40 degrees. Record the intensity. Make it 50, 60, 80, then basically up to 90 degrees difference. So we can see that the light becomes 2,900, and this actually reminds you with what? Reminds you with the initial no light intensity offset that we had at the beginning. So that means actually the intensity right now it is 0 due to the angle difference of 90 degrees. So if we turn it back to 0, you can see the light intensity goes up until it becomes 3,412. Okay, let's remove this one. Then basically this is the experiment for the light polarizer. I hope you liked the lab for today and you've learned something beneficial. If you liked it, please press the like button and subscribe, and wait for me for our next physics lab. Thank you.
Inverse square law, it's easy to see.